Welcome back from lunch, everybody. My name is Hanson Ho. I use he, him pronouns, and I am a medium-ish build Chinese guy with a receding hairline, dark glasses, wearing a yellow t-shirt or jersey of my football club that I support, Watford FC, Ewons. Today, well, right now I am working Android at Embrace. We are a performance, we are a mobile observability platform that optimizes and helps you bring your users the most delightful experiences. What actually I'm here to say is not what I learned at Embrace. I've only been there for 3 months. What I'm going to talk about mostly is what I learned at Twitter, where I've been for a lot longer doing performance and stability work on the Android app, specifically on informing the talk is what I did there, which is I'm going to talk about sampling biases, performance metrics, and user growth. Now, first I want to ask one simple baseline setting question. It's why you want to work on performance. Well, for me personally, I work on performance to keep my users happy. I don't want them to give up using the app because things are slow or things crash. I want the features to stand out and for performance not to be an impediment. I want to keep my users. And how do I do that? Well, I use data. Data allows me to tell what the user is doing. It is my eyes and it is my ears to what the users experience. Product analytics tell you what the users are doing. Perf metrics do a little bit more nuanced thing. It tells you how your users are experiencing your app. Data gives you user experience information. And not only data, it's data and analysis, because data, all it is are numbers. You need to turn those numbers into useful insights. And you do that by having a good analytical process to transform that data and inform your decisions. So what you're after are good data and good analysis. And you do that by reducing sampling biases in performance metrics. And you do that for production performance metrics because that's what tells you is happening for your users in real life. So today I will cover the following. First, why you want to use performance metrics in the first place. And then I'm going to discuss about sampling biases, specifically what they are, 3 specific biases, why you would care about these biases, and what you can do to mitigate their effects, and ultimately, how they impact your user growth. Now, perf metrics in a whole, there are a lot of things to talk about. So I'll also talk about what I will not talk about. I will not talk about how you identify regressions. Comparing 2 big sets of data and telling if there's a regression, that's a whole different talk, a lot of stats. And I promise, no stats. I will also not talk about specific metrics that are useful for performance growth, because depending on your situation in your app, those could differ quite a bit. I will also not go into sources of metrics for performance. You can get it from Google with Android Vitals, you can have your bespoke collection and data pipeline, or you can use a third-party mobile-specific observability SDK that helps you bring delight to your users. But I will not talk about that here, right now in the presentation. I'll talk about that later with you, though. So let's get into it. Why we use production performance metrics. A lot of people, when they do performance, they think about benchmarks. You can isolate a specific test, see how long it runs in a very specific environment. You are able to determine if there are regressions, if code changes affected how long specific operations run. Benchmarks are fantastic for catching regressions. You use macro benchmarks, micro benchmarks, third-party tools, mobile.dev to help you catch regressions with benchmarking. But production performance analytics do something slightly different. They quantify user experience. real user experience, not in some setting running in some lab on a specific device with a specific state. This is the wild, wild west, people. Everybody using your app in weird, weird, wonderful ways. And perf metrics in production allow you to capture that, and capture that as data. And why is data great? Well, data is great because you can compare. You use data to compare performance tests, but we can use production metrics to compare what you and your users are expecting and using in the wild, the spectrum of users. You can also compare with other people, some well-known performance metrics like app starts. You can see if your competitors work as well as you. You can also compare with expectations. Do you think your app is running a certain way, and can you verify that? Well, you can do that with performance metrics in the wild. If you added a feature and you wanted to know if it slowed down app startup, maybe it did in the benchmarks, maybe it didn't. But production metrics will tell you whether it affected your users or not. Production metrics really have no substitute because they provide a lens into what your users are experiencing. So it's important to make sure that they are as good as possible. And that's why you want to reduce sampling biases. So let me first define what sampling biases are. Well, they are, broadly speaking, issues in data collection that make samples that you collect not representative of the population where it comes from. That's great, but I also want to introduce a second element, which is the analysis part. I want to define sampling biases as collection issues as well as analysis issues that distort reality, that make the data not represent real life. I want to talk about systemic issues that distort reality. So let's get into it. Oh, my mouth is so dry. Sorry about that. Oh, let's get into it. Overrepresentation of heavy users is the first sampling bias I'm going to talk about. So if you work with perf data, this should be intuitive to you. If your users use your app more, they send you more data. Heavy users send more data. That's a tautology. But that can be problematic sometimes, depending on how you look at that data and what that data thinks it's telling you. So let's use an example of a data load time metric. This is contrived to illustrate my point. So imagine if you have 3 sets of users. You got your heavy users, you got your medium users, and you got your light users. They use your app in varying frequencies. They also have different sizes. Your heavy users may be one size, medium users another size, light users another size. By percentage, your heavy users are 20% of your total users, and your light users are 20% of your user base. The rest are medium users, 60%. The majority of this data set users are medium users. Now, what if you look at it by data point? How many data points do these groups generate? Well, heavy users actually generate 51% of all data points. Medium users, 45%. But light users, only 4%. So you have 2 groups, heavy users and light users, all generating an order of magnitude difference worth of data points. Again, intuitively, you know that. But should you care? Well, it depends on your app. If you're a subscription app and all users are important, if your data is telling you more information about your heavy users and less about your light users, it may be easy to ignore your light users. Specifically, what are we talking about when we talk about percentiles? The 50th percentile, the 70th percentile. They're not your users. They are data points. The median data point is the 50th experience. But it's not the 50th percentile of users. You know this, but just want to make it out there. If you're looking at data in the first time, you're looking at P95 and you think, well, that's an outlier. It is, sort of. So I'm going to tell you a little story right now about my time at Twitter and what I learned by looking at lots and lots and lots of data points. That performance is not evenly distributed amongst your user base. Typically, users that use the app more experience better performance. There is a correlation if you look at the data. There's more data with good performance than there is data of bad performance. The distribution is skewed to the good performance side. Let's revisit the previous example. We're going to add duration to what the users are experiencing for loads. With my previous experience, heavy users get faster loads and light users get slower loads. This is what you get. And let's examine the percentiles and the aggregate metrics, shall we? So what's P50? Well, P50 is what, 500 milliseconds? That's what a heavy user sees. Odd. Heavy uses 20% of users, okay. Well, P95, an outlier. What is P95? It's a second. It's what a medium user sees. But isn't P50 an outlier? What about light users? Well, unless you go beyond P95, light users aren't even represented in your percentiles. P50 is not users, it's data points. So you can't say that 95% of your users are experiencing your app at P95 or better. Users with bad performance, you cannot tell with just metrics where the unit of analysis is data points. You can't tell how many users fall into that category. That user group could be a lot bigger than you initially thought just by looking at the P95 of a metric. So what can you do? Well, previously you were using data points as your unit of analysis. Well, what if you use users? Instead of having multiple data points contributed by a single user, reduce all those data points down to one. So every user contributes one data point to your sample size, to your sample. This is what Google does with app startup times in Android Vitals. It takes the first occurrence of cold start, and for that day, that is the cold start time for that user. You can start 10 times, you can start at 1 time, still one data point within that day. So using users as a unit of analysis, let's revisit our previous example. And because this is a contrived example, it's easy to consolidate all data points for a user into one because it's all the same. Heavy users, 500 milliseconds, light users, 3,000 milliseconds. But instead of having multiple data points, each user is one data point. So what is P50 now? Well, P50 is 1,000 milliseconds. It's what a medium user sees. That's with an expectation. P95, well, that's all the way up to 3 seconds. It's what a light user sees. It is an outlier. And light users, in fact, are represented all the way down to P81. And that's because the entire user spectrum is properly represented. What you're looking at are not data points. What are you looking at are users. P95 is 95% of users, or rather, 95% of users get P95 or better. P96 then truly is an outlier. That's the first one. Overrepresentation of heavy users. The second one I'm going to talk about, the underrepresentation of users that you've lost or are going to lose to bad performance. Now, we know that bad performance tends to lead to churn. It's not the only reason users stop using your app, but it's a key one. If you load up an app and it's too slow for you to use, what do? You stop using it. What happens is that you, as a user, you get into performance metrics for a brief amount of time. You get it, you use it, you uninstall it. It shows up in metrics briefly. Churn means those users report no data in the future. Or they reduce their usage, so they report a low amount of data. That means the people you've lost is not in your perf metrics or represented a fraction of your regular users. Lost users is a percentage of your current users who will give up in the future because your app is too slow. But it is also users you've lost in the past who once used your app, but no more because of bad performance. As well, they represent a fraction of the market that haven't even tried your app, but because their phone is not really super great at performance, using your app, they found it to be too slow, and they stopped using it. A person with a brand new phone, Samsung A14, a Moto G Play 2023 edition, so it's new. They use your app, they install your app, oh, performance is bad. I'm not gonna use it anymore. The problem of performance and churn is especially acute on Android, simply because of devices like that. They are brand new, but they don't work so well. Not only do you have low-end devices targeting low-end markets for very low prices, you also have the legacy devices, the ones you pass on to your parents because you no longer need it, you have a better one. They have old versions of Android running, and they have old hardware. This market segment is massive, and you may not see them in your app metrics because they can't use your app because it's too slow. Not your fault. The phones are just not super great all the time. This group of users represent negative recurring revenue. A user you lost yesterday is going to cost you today, tomorrow, and in the future. This is like annual recurring revenue, except negative. It also reduces your total addressable market. There are people out there who haven't tried your app yet, who would love to use your app, but they can't because their phone is just not going to work. Now, how many users is that? How many users have you lost to bad performance? Can I tell by looking at your perf metrics? No, because those users aren't in those metrics. And why should you care about that? Well, I hope I don't have to tell you why you should care about losing users. But ultimately, you want to collect performance data to tell you about user churn, among other things. You want to keep your users. Metrics are supposed to tell you that. If they're not doing their job. Well, that's because performance metrics alone cannot predict or quantify impact. All you have is the number, how long it took. It doesn't say when users will quit, at what level. Well, it doesn't tell that to you alone. You can certainly use it as part of a process to find that out. But first, you need to quantify your churn rate, especially with how performance affects it. You need to find that relationship because then you can figure out, is bad performance worth fixing? Now, how do you do this? How do you marry churn rate with performance metrics to determine how much bad performance is costing you? Well, you find a relationship between the two of them. If you change X by a certain percentage, Y changes by a certain percentage. And the best way to do that is through A/B testing, where you divide your user base randomly in a random sample and change one dimension, performance. At Twitter, we put that to great use with a holdback experiment that lasted for months, one that lasted over a year. What we did was improve a very specific metric, something called time to first tweet. It is basically app cold start plus the loading of cache. We made many, many improvements and then put it all in one experiment and see what it looked like in terms of how it affected metrics as users keep using the app for months and years, well, a year. Why did we do this? Well, we want to demonstrate our impact. it's hard to quantify what a performance team brings to a company. You have anecdotes, you have gut feel, you have vibe. That's not really enough. With this experiment, we were able to improve time to first tweet greatly. Not only that, it led to a lot more DAU and users. Now, these experiments alone, run for 2 or 4 weeks, did not actually impact core metrics. It moved the performance metric, but the core metrics, not as sensitive with just one change. But when you combined it together, that's when the magic happens. That's when we found a lot more DAUs and a lot more users by improving that one metric, time to first tweet. The improvements are so great, actually, that it justified the existence of the team if the only thing we did was improve time to first tweet. But we did a lot more. Now, not everybody can do A/B testing. It takes time, it takes effort, and most of all, it takes a really large user base so you can get representative data and large enough power to prove relationships. So what can you do if you can't do A/B testing? Well, you could look at your existing data and basically try to tease out relationships in amongst your user base as you divide them by various dimensions. First, you would use users as a user unit analysis. You would divide them into groups based on how well they performed. These are the slow users, these are the fast users, these are the medium users. And you pick one metric, like TTFT, like duration, whatever you track, you can pick any metric. And you'd want to ideally restrict that population to users that are most likely to churn, because people who've been using your app, even if they have bad performance for a year, they've gotten used to it because they're still around. So what you want to do is actually pick a group that will most likely give up using your app if things are bad. So you are really restricted list to new users because they're going to be the most sensitive. And if you, through this process, find statistically significant differences in churn rate, jackpot. You have found a correlation between perf metrics and churn. Oh, yeah, let's do this then. Ooh, not so fast. This is only a correlation, so you got to slow down. This is not A/B testing. You have not found the relationship that's reproducible. Mere annoyances, they don't actually affect churn. And of course, correlation is not causation. There could be underlying factors that affect both of them. That is the true cause of churn. You can't really tell that with this type of analysis. Not that it's not useful, it's just fairly limiting. And you have to know when to use this. As a hint for A/B testing, if you have hundreds of perf metrics, which one do you A/B test to see performance? As I said, it takes time and effort to run these experiments. You can't do them all. Well, you can pick one that has a correlation, narrows it down. You can also time box your work. Invest 2 weeks to improve a metric that has a correlational relationship with churn. Worst case, you lose 2 weeks and you get a slightly better app and don't get churn improvement. But it's only 2 weeks. If you limit the time you spend, you actually can try this out. And the best case is it actually does improve churn. And then you can reinvest, do more testing, or just keep working on it until it stops. What you can't do with this is come to definitive conclusions. Don't bet the farm that this relationship is real. Simply use it in a limited way and see if it helps you. Whew, more water. Now we've come to the third bias, missing data from incomplete operations. And frankly, this is the classic sampling bias. Perf metrics, what are they? Well, there are many things, but typically, you want to track how long it takes to do something. You're measuring duration of operations. You're specifically measuring the duration of completed operations. You go to Android Vitals, you look at app startup time. Those are measurements for when app startup completed. But not all operations actually complete. In fact, if duration of an operation goes higher, what you typically see is more users give up. They simply don't finish the app startup because it's taking 15 seconds. Therefore, you get more incomplete operations as duration increases. And when you collect data only when operations complete, you get the classic survivorship bias, which is basically when you only collect data if the sample passes some hurdle, which implicitly has a bias. This is the image most people think of when they think of survivorship bias. You got the plane from the war coming back, landing with bullet holes. And you might want to figure out from the bullet holes where planes get hit so you can reinforce it. Well, planes that land, you often see this. No bullet holes or few bullet holes in the cockpit or the engines. Or does that mean that cockpits and engines don't get hit? Well, no. If a cockpit gets hit and an engine gets hit, the plane goes down. It doesn't land back on the base, and it doesn't get counted. But it doesn't mean that the bullets didn't hit those places. It just means you don't know they did due to how you're getting your data. Well, incomplete operations are the bullets that hit the plane and brings it down because we don't collect them often. Some people do, but a lot of people don't. And you know what? We should track those bullets. That's ultimately what we care about, is the impact of performance. If the impact is actually stopping an operation from otherwise succeeding because users give up, we should care about that, shouldn't we? Now, perf data is noisy, but major performance regressions should be able to determine big regressions in production. Small ones harder because of the noise, but big ones, you should be able to tell. But without counting incomplete operations, it's maybe a bit difficult. So I'm going to illustrate with another contrived example. We're going to have 4 user groups who experience a particular metric. We'll say load time in 4 different ways. Yeah, fast users, medium users, slow users, and really slow users. They have different counts, each group. Cool. And what if we apply a 20% regression to all of them? So every single of these groups used to behave and have durations of a certain time. It's all 20% slower. Now, fast users, medium users, even slow users, that didn't change the behavior. The same number completed. But for slow users, 5 of them gave up and they stopped letting the operation complete. Let's see what this does to the aggregates. And you have to believe me here, I did the math twice. Actually, the computer did. So you can definitely trust that. There is no change to mean. 20% regression, no change to mean. P50 went from 200 to 240. Cool, that's 20%, that's expected. P95, whoa, what? It improved from 2 seconds to 900 milliseconds. How? I don't get it. 20% uniform. Well, it's because the distribution changed. Some data points are no longer there. Some really slow data points dropped off, which actually drags up your mean and changes the distribution. And so the percentiles are all different, giving you different stories. And it's hard to tell that in production because of the noise. Week to week, the number of usages change. Unlike this contrived example, you don't know simply by looking at completed operations that there was an increase in failures because you're not capturing any failures. So what do? Well, you capture failures and calculate a success rate for metrics that are duration-based. With incomplete operations, you can get the total. You can get the denominator, and therefore calculate success rate. It augments what you get with the absolute number and tells you what actually happened to that operation. Here's another story time. At Twitter, we used this to great effect with A/B testing because it allowed us to actually have a more sensitive metric to look at. Sometimes the actual mean didn't change or didn't change statistically significant enough. Success rate did. So we can change some dimension of performance and see a change in success rate, even if we didn't see it for the mean or the P50. It is also easier to quantify and determine impact. You don't know what it means when things are 5% slower. What does that mean? I don't know what that means. But if the reduction of success rate is 2%, we can quantify that. If your data refreshes fail 2% more, you know how many fewer ads you're serving. So let's revisit our previous example. Complete, incomplete. We track both now. Cool. With the changes to regression, new incomplete for very slow has increased. And therefore, success rate went from 80 to 76. So even though the aggregates are still kind of confusing, you can actually tell that success rate has gone down. This is super useful. Robust performance metrics require success rates. It allows you to know when things failed at a greater clip. Now, let's bring this all back and tie it together to growth. How does this impact growth? Let's review. Data is a proxy for user experience. Sampling biases make data worse. Sampling biases like users being overly represented if they're heavy, users who churn being underrepresented, as well as incomplete operations not being quantified in your metrics. Now, to clean that up, you use users as your unit of analysis. You determine churn due to bad performance. And you also calculate success rates to give your performance metrics a bit more flavor. All this is to serve to improve the quality of your data and to better answer one specific question. How much is bad performance costing you? If your data is bad, you can't answer this question precisely. Without data, you don't know what aspect of performance could be impacting you the most. How do you prioritize which perf bug to fix if you don't know how they affect the underlying user churn or some other core metric? You want to know how to improve a specific aspect of by X in order to keep Y more users. You want to answer this as precisely and as correctly as possible. And good data, free, or at least a reduced amount of sampling biases, it helps you with that. So I've talked a lot today about sampling biases, mitigation tactics. And if you leave this with one takeaway, I want you to leave it with this takeaway. That performance is a feature. It's a feature that increases user growth. Not only do you gain new users by releasing a brand new feature, you could get it by simply losing fewer users. Because what is user growth? It is the users you add minus the users you lose. If you lose fewer users, your user growth will be higher. Performance is a feature. It is not a chore that you have to do because things have gotten bad. It is a feature whose impact you can quantify. You can say you work on performance and you increase DAU, you increase users. You can't really do that by adding a brand new page with a doohickey. You can estimate, you can use vibes to figure it out, but that's a guess. If you use performance data, you could actually put a number to how much performance work is worth. Again, one takeaway, performance is a feature to increase user growth. And you do that by reducing sampling biases. Thank you very much.